this will work. I had trouble recording sound before. Okay, so I want to show you something different today. I often get the question from students or fresh graduates, how do I improve? How do I get ready for an interview, a coding interview? And obviously the amount of coding that we do in this class is very little, not enough to get you ready for a real either programming job or even to work on a project where you need more sophisticated programming. So obviously we're just breaking the ice a little bit here. We're just starting. Should you need more practice, the good news is that there's a lot of opportunity. So I'm going to show you a few sites that are trying to help coders that are beginners to get better. So probably the oldest is this one, LitCode. All right, and you will need to create an account if you really want to get serious about it, but you actually don't need one if you just want to dip your toes. If you press here on Get Started, you'll see that there are a bunch of lessons. All right, but if you just click on problems, you can go straight here, and you can pick a problem. I'm going to pick one that is really very easy, or should be very easy to solve, right? And you have a problem statement here, and you have an environment here where you can actually type your code and submit it and see if it works, right? Going back, and actually you would have the solution as well if you really want to cheat. But I think if you have an account and if you look at the solution, you don't get credit or something like that. And in general, the site will try to keep track of your progress, and you get a good idea of how good you are in doing these things. So let's just try to solve one here, just for fun, especially because in Python, this kind of problems are very easy. There's a lot of languages available here, right? So if you're not a Python programmer, you prefer a different language. Well, my preferred one is not here, but my second favorite one is, which is Scala. My favorite language is Haskell, not here. And there are other ones that will have that one as well. So let's look at what the problem says. It says a very, very simple thing, right? Take a number, reverse the digits. It turns out that this is a trivial problem in Python, because in Python we have the different data structures like string and integer and so on, and we can convert from one to the other very quickly. Right? So for instance, if I have the number 1, 2, 3, if I check the type of this thing, right, I would get class int. If I would check the type of this, I would get class string. And guess what? Int and string as classes, they are also constructors for those objects. So if I say str, and I can put here anything, that thing will be converted into a string. If I say str of 1, 2, 3, I will get back the string 1, 2, 3, right? And once I have a string, the string is a sequence, so I can say reverse, right? Can I say reverse? Maybe I should do help first. And not help, dir. And do we not have a reverse? If we don't have a reverse here, then we can say reverse of str of 1, 2, 3, or revert. No? Cannot be. reversed. Okay, reversed. This is the one, right? And remember, whenever we are doing these functions on sequences, what we get is a lazy object that contains everything, but it will only reveal it when specifically asked, right? So I can turn it into a list, for instance, right? And I will get this. And I might even be able to turn it into a string. It will still be a reversed object. So I think we're going to stick with the list. We're going to stick with the list. And if you remember last time or a while ago, we learned a way to convert a list of objects into a single string, right? So the way to do that was to take the separator. So for instance, just for fun, I'm going to take the colon and say join, I think. And I'm going to use the list 3, 2, 1. I'm hoping this will work. Expected str instance int found. Join. Let's find the s.join. Yes, what was wrong with that? Sequence item 0, item 0 expected string instance int found. Oh, everything has to be a string. Okay, so we're going to say map str this. So we're going to get 3 to 1, right? So let's take them one by one. So we're back to list reversed, right? This is already a list of strings. Actually, I don't even need a list here. So I'm going to say, let's just for fun say dot and join this. And I'm going to get, right? So the first string, this string, becomes the separator between all the elements inside the list, right? And if I say here the empty string, I'm just going to get 3 to 1 back, which is exactly what we wanted from the very beginning, if you remember, right? We wanted the list, the integer to be reversed. Now this is a string. How do I get it back into an int? Louder. Int, right? So we use string to turn it into a string, and then we're going to use that back, and this is what we need, right? So this is the solution to our problem. We can very easily develop it. So let's actually be lazy and just cut and paste. So here what we want is x. All right, and this we need to return. We're going to wonder, what's this class here? We're going to learn at some point. This is an object-oriented language, all right? And it deals with, we have to be able to create objects, right? This is an aspect that is not central to Python. We can do a lot of things without actually being object-oriented. However, this framework where our solution is evaluated works better if we submit an object rather than just a method. Right, so we put this reverse method inside a class. You should not worry about that, and this self is there because of the class, and we can ignore it for the time. So we have developed a solution. We can click submit, and now we get asked to sign up, to sign in, or so I do have an account. I actually don't remember my password. That's the problem. Otherwise, I would have been, and I don't want to spend time finding it out or resetting it. But that's what it would be, right? So feel free to get an account and go through these exercises. they're the best exercises if you want to learn programming, and you can do it on your own, at your own pace, for free, pretty much. There's many such sites. Another one is Codility. I'm not working for any of these companies. I use these sites a lot. If you ever research how to get a job as a software engineer, you have to go through a so-called whiteboard round, and a lot of companies will have several. And in my life, every job I got, I had to go through such a round, right? Where you get for this sites you get a medium level, not a hard one, but a medium level one, and you have to solve it in an hour with complete code. And this was how I trained. No matter how well prepared theoretically you are, solving a problem like this in 1 hour correctly while under pressure is a skill that needs to be developed. All right, so I highly recommend practicing code on this, right? This is another site. This is a site that actually organizes interviews. So employers can send you a link where you open this kind of a problem. It's an environment where you are working against the clock, right? And when the time has elapsed, everything closes, and if you haven't submitted, then you essentially haven't solved the problem. And it has a lot of lessons, and the lessons are in a similar fashion, right? There's some reading material, and then there's a problem, and you can simulate actually the interview. So you can say, oh, I want to have 20 minutes for one task, right? This one, Codility, has very well chosen problems. The other ones, most of them have user, they're not curated, right? Users just submit problems, then the ranking of whether they're difficult or easy or medium comes from other users and comes from statistics, right? So it will look at how many failed submissions there are. When you submit, if the solution is not correct, it will be automatically tested. It will appear as a failed submission, and based on that, it will decide whether it's difficult or easy or medium. This one is curated, right? So it's probably a bunch of people who know what they're doing, have chosen the questions very well. So it's a lot better. It's a lot more useful. There's HackerRank. Okay, sign up and code, and so on and so forth, right? If you look for a hacker website, and it's already suggesting stuff. All right, so you get HackerRank, you get Hacksplating, Code Hacker, Hacklang, and so on, right? So you can you can look for they're like mushrooms after the rain nowadays, because becoming a coder is a very popular thing. Being a coder is not so popular. Becoming one is a very popular thing right now. So there are all these boot camps and all this preparation for boot camps. It seems like something that is very lucrative, helping coders get better. Cool. But a lot of the resources are for free, and I would recommend not paying for anything, just taking advantage of what the free stuff that is out there. Cool. So enough about this. Any questions about this part of?
Like, is it enough for us just Google hacker coding website? Like, are these websites are trustful?
What do you mean? Like, so quite a few of them I actually haven't seen before. I think Wikipedia would be actually much better. So if I look for hacker rank here. All right, so the competitive programming, all right, so that's one thing. No, so this is a type of site. I can't remember what the type of site is, but all right, so you see the good ones here, right? So Taupe Coder is also a very good one. Um, um, Code Chef is quite good. This one I haven't heard of. But if you go to all of them, then they're kind of network. This one will have a C also as well. So this is a bit better. It has Kaggle, it has the ICFP programming contest, which is on functional programming. It has SPOG. SPOG is one of the sites that has the widest variety of languages. So if you're a fan of obscure languages, like there's another language that I'm quite a fan of, which is called Prolog. This is pretty much the only site that has that. Yeah, more questions? I'm wondering now how many of you will actually go and solve a problem there. But good, at least you should know. This is by far more useful than reading a programming book or watching a video tutorial about programming. Right, going and doing stuff on your own is infinitely more useful. Okay, so about today's lesson. So I want to do two things today. One is work a little bit on strings and sets. We haven't experienced sets. Maybe sets first and then strings. So we have, with strings, we have finished covering all the possible data types that are available in Python, and maybe work a little bit on some algorithmics, right? Some algorithms. We haven't experienced that, and I know that you don't have a lot of experience in programming. So there are a lot of high-level functions in Python, like sorting, right? Finding the minimum of a list. And you might wonder how to do that. If that weren't available in Python, if you were in a language like C, how would you do that, right? So I would like to explore that a little bit and get you to think about low-level operations a little bit more. You're not going to do that in terms of the operations or the algorithms that we're going to work with today, but every once in a while the need arises for you to do something like that, and you at least should have some exposure. So let's start with sets. So there's an important thing about sets and dictionaries. We discussed last time that sets are just a special case of dictionaries, right? A dictionary is a mapping from a key to a value, and then if the value is, we don't care about it, we just say by default it's true, then what is important in the dictionary is only the keys, and what we have in the end is a set of keys. It is important to understand what can be a key. Not everything can be a key. All right. So how are dictionaries stored in memory? Right. They're pretty much stored in memory as arrays. So Python will think, oh well, how many objects does a user want to put in a dictionary? Usually it will think of a power of 2, right? So to the power of 10 is a good number because it's 1024, which is around 1000, right? So thinks, well, maybe 1000 elements, right? So it creates an array of 1000 elements, and anything you try to put in the dictionary, it will try to convert the key into a number between 0 and 1023, right? And not everything is convertible into a number, right? Many things are convertible into numbers, but not everything. All right. So once in a while, you're going to try to create a set or a dictionary of things, and Python is going to get upset. And the reason why it gets upset is that that thing that you try to use as a key cannot be converted into a number, right? If it can be converted into a number, it will be placed in the array at the location of that number, right? If I can convert it into a number, then I can take the modulo 1024, and I can convert it from whatever number into a number between 0 and 1023, and I can just go into that slot and put it there. What if there's a clash? What if later I convert something else into a number and I go to a place where it's already occupied? Well, I'm going to have a list of things at that array element, right? The array element doesn't point to a single element, but to a list of elements, right? How long should the list be? Not very long, because otherwise the search becomes very slow. What happens if I put too many elements in the array? It will try to take it from an array of 1024 elements to, it will scale up one level. So from 1000 elements, it's going to go to 1 million. 1000 times 1000, right? And it will take all the elements from the old dictionary, put it into the new dictionary, and keep going. Right? The number that you get out of a key, right, to use as an index in the array is called a hash. Right? It's a very important operation. Producing good hashes is difficult, but it's a solved problem. There's procedures to do it. Right? And therefore, dictionaries are also called hash tables, and you're going to hear that a lot. And also, hashes are very often used as identifiers for a piece of content, right? You will have this kind of hashes where the clash is very unlikely. It's not impossible, but it's very unlikely, right? Sometimes that is also called a digest. And then you can use the hash as an identifier for the object. The one thing that you need to remember is that you can't always convert something into a hash. So things that can be converted into a hash are strings and numbers and combinations of that are immutable, right? So a pair of numbers or a pair made up of a string and a number, that's hashable, right? If I want to hash a list, the list is mutable. We cannot use it as a key. Okay, so let's verify that. Okay, so if I have a dictionary where we start with 1 and A, right? So it has one entry, D1 is A, right? This thing now has 1024 elements. It's an array of 1024 elements, but 1 gets converted into a number, not necessarily 1, all right? And then we go and use that location. And then I can always put D 1, 2, or 1, let's use a string B, to have a value of C. And I should do it in this way, right? So if I do this, then I can check that 1 and B has the value C. I can also say keys D, I think, or D.keys. D.keys. And I can see what are the keys, right? There was 1 from here, and then there's 1B from here, right? So you see it as a list, 1 and 1B. There's 2 keys in there. Now, if I try to use a list here of 2MB and put a value of 0, let's say, sorry, I forgot so this is a list, so I have to have 2 levels of round brackets. It will immediately say unhashable type list. Why? Because the list is mutable, all right? Immutable stuff works well, mutable stuff doesn't. And immutable combinations of immutable things will keep working, right? So I can have a tuple of tuples of tuples of tuples, no matter how many levels, that will still work, right? As soon as one thing inside there becomes a list, it's not going to work anymore. Is this clear? All right. All right, strings. So strings are still sequences. So everything we could do with sequences, we can still do with strings. For instance, we can say sorted of something like this, and I'm going to get back a list where all the elements in the in the string appear in alphabetical order, right? So a string is essentially a sequence of characters for most purposes, but we have quite a few other methods or operations that we don't have on most other sequences, right? One is a check whether a string starts with something or ends with something. So for instance, I can say A, B, C, D starts with starts, where is it? Starts with, you see it here. And AB, I'm going to get true. If I try to use AC, it's false, right? I can say ends with, and CD, true again, right? Contains. Contains, is there? Is it there? Center counting code. Contains is not in. All right, but we have index. All right, so I can say index and CD, and I'm going to get index 2, right? If this this is a string that doesn't appear inside, I am going to get an error. All right, we're gonna see what we can do with these errors soon. All right, another thing is, I think, find. Oh, find. We have find here, so I can do ABCD find CD, and I can see it's 2. If I say some other string that doesn't appear inside, it returns -1, which tells us that it cannot be found. We can do replace. Replace will return a completely new string. The old string would stay the same. And I'm going to make this one longer. Right, replace, and I want to replace DE with XYZ. All right, but the old strings are immutable, right? And so we can do something like this. I can say this converted to upper, I think. Yes, I can take an upper string. So now we know that, so S is this. So S is uppercase. I can say S lower, and it becomes lowercase back. I can capitalize, right? So S lower, let's make this T, S lower, so T is all lowercase, and I can say T capitalize, and it becomes capitalized, right? We can split a string. Let's see how we split. Can we just split it? All right, so I'm going to say help split, and split will tell me the separator, and we'll produce a list of strings. I have a max split which defaults to -1, and we don't care about it, right? So let's say I have a list of words. My word list is A, B, C, D, F, G, H, I. Normally we separate words by spaces, and I want to say F split with space, and what we get is a list of strings, right? Each of them being a separate word. So for instance, if we want to capitalize every word in W, how do we do that? Right, so we do W split, all right? Then this is a list of strings, so we can map on it, right? Map, and what would be the function? The function would be lambda, right? S and S dot capitalize. And remember that this returns a lazy object. Let's just see the lazy object, right? So we don't see what's inside. If we want to check what's inside, we can put all this inside a list, right? So now we have capitalized words. And we want to reassemble the string together. We want to put all the words together into a string. How do we do that? Space, join, all right? And this will create the string back, right? So this is a very simple one-liner piece of code that takes a string, the string W, right, and capitalizes every word inside that string. Does it make sense? This kind of operations are very common. Is it clear? Because some of you are squinting, and that's a sign that. Okay, so how do we take this now and make it into a function? So we can say def words, and we're going to say WL words. Let's be explicit. And I'm going to just copy this, and this is going to be words, right? And obviously, I have to return this. Okay? Now, whenever we have a map, we can always replace it by a comprehension. Unfortunately, we can't have string comprehensions, but once we have done words.split, we're actually having a list of strings, right? So a nicer solution will be to replace this with a comprehension. So we can say it's the list of s.capitalize for s in words.split. And I have to close the list here, right? And to make it even more readable, let's take this one out and say capitalized words. All right. And here we would say capitalized words. Does it make sense? So, in the good spirit of the way we worked before, let's write a test. So print I have to use a string, the And notice how I can alternate single and double quotes of the rain in Spain stays mainly. Do you know where this is coming from? And because this is a relatively long string to a test string. Yes, do you know where it comes from? Have you heard of Pygmalion? George Bernard Shaw. That's something you would read these days, huh? Okay. Is, and we can say colon and say capitalize words of test string. And then we can go and run this. So Python 3, Python week 3 Thursday, right? Okay, so we could put a \n here just to make it more readable. And if you don't know what it means or where it comes from, you can always Google. All right, this is the musical. It's quite a famous song. And 5 words that Cockney would pronounce. Okay, so it comes from display. English lit lesson, or the English lit side of part of teaching Python. Cool. So this is a very simple lesson about using strings and stuff we can do with strings. All right, let's try to work a little bit on our algorithmics, right? So I want to write a function that finds the minimum of a list and a function that sorts a list, produces the elements of a list in sorted order. And we have solutions for this out of the box, right? So if I go here and I say min of right, I will get it immediately. If I say min of a string, I will get it immediately, right? And so on and so forth. But what if this function didn't exist? All right, and we can do it in several ways. So let's explore all those. Diff. So my min 1, and we're going to take a list. We're assuming that they're numbers, but it doesn't matter. It's as long as they are comparable, it should work. Okay. So what's the minimum of whenever we look at a list? What do you think about? There's 2 very clear-cut cases. Whenever we have a collection.
So the minimum should be longer than every.
Yes, but yeah. So, but my question was, whenever I look at a collection, what cases should I consider? Louder? Empty, right? So you see, if the list is empty, I cannot take one element, pick one element from it, right? If it is non-empty, I am guaranteed to be able to pick an element from it. The act of picking an element from the list is guaranteed to succeed, right? What would be the minimum of the empty list? Again? Yeah, you can say nothing, right? In principle, it's an error. So we can deal with that error in two ways. Either return nothing, which in Python is called none, or throw an error, right? And we can let that error throw itself, right? So let's return none, because that's it. That for the time being is the simplest solution using what we know. So if len L is equal 0, return none. L if. All right. So what else can we check? In terms of minimum, is there a case where we can very easily say this is the minimum? It's only one element, right? So len L equals 1, right? Return L0, right? L0 is guaranteed to exist. I will not fail at that point, right? And what do we do otherwise? Again?
Iterate through the list.
We can iterate through the list, right?
And have a stored variable called.
Okay. So all right.
So it's checked
All right.
against.
Cool. That's gonna be our min 2. Something that you can do immediately and do it now, very, very easily. No. I don't want to define. I want to define sorted in terms of minimum. I never want to define minimums in terms of sorted, right? Minimum function, yes. You can't use the minimum that is predefined, right? But so I have something that is larger than 2, right? So I can say rec equals min L. Does this help? My min, of course. So recursively, I can compute the minimum of a smaller list. I take the first element away. Does that help? Yeah, so we haven't checked. Maybe we can check it now, right? Doesn't mean that I can't still check it. Doesn't mean that I'm done. So what I'm asking is, would this help? So let's look. What can I return for this? What possibility is none, right? I can't remember. Let me go back and remember my Python. Okay, so this is how it works. So is none. Then So is actually this case possible? No, right? Why? Because this list should have at least 2 elements. Right? So if rec is none, actually shouldn't. So if rec is smaller than, return yes. Very good. Okay, so this would be a minimum. Right, so the minimum recursively is, I have to, am I able to compute the minimum of 2 numbers? Yes, because I can do this function, right? So let us make it even more readable. So we can say def min 2, which is the minimum of between 2 numbers, x and y. Right, if x less than y, right? And then instead of writing this, I can just write return min 2 between L0 and my min L1 onwards. Okay, does this look better? Yes? Okay, let's see that it works. So min of 4, 3, 2, 5, 3, 1, and again, based on our good tradition so far, let's just say test list equals this. Is, and we're going to have min, my min 1. I forgot a colon. Okay, so it's correct. All right, solution number 2. So let's define my min 2. All right. So again, there's no minimum for the empty list. So if len L is 0, return none. Else, so let's have a variable, all right, and we can say current min equals L0, right? L0 is guaranteed to exist now because the list has at least 1 element, okay? And then for, right, for x in L from 1 onwards, all right, what do we do? But we're already doing that here, right? So I can say current min equals min 2 between current min and X, right? And once we finish this, you can say return current min. Does that make sense? And we can go here now and replace my min 2 here. After else, very good. Thanks for saving time. And we run this, we get the same result, all fine. Okay, so we have two methods of computing the minimum. All right, is this clear? Let's leave a piece of space here. Okay. Cool. So now let's try sorting. For sorting, we're going to have many methods. There are many methods to sort a list. Before that, let's repeat this test. So we were talking about polymorphism at some point. All right, so let me turn this into a string. Ah, interesting. Right, and test list, test string. And let's do test string here. Sorry, test string here. So minimum of that string is C, right? So it works automatically for a string. It worked for a list, and without making any change, it works for a string. All right? Why is that? Because the string is a sequence, because characters inside the string are comparable, right? And then there's nothing there to cause a problem. If I change the list into a tuple, same thing. Okay, it's interesting. For instance, if I'm going to change this list into a list of pairs, so pairs, interestingly, are also comparable, right? So 2, 3 less than 3, 4, and I get true. And if I say 1, 4 here, I get false. How do you think comparison happens? And I can even say 5 here, and they're comparable. How do you think comparison happens here? Okay, let's take it slowly, right? So 1, 1 equal, we know less than 1, 1, right? This is false. Less than 1, 2, this is true, right? Now if I say 1 here, I put it back, and I say 0 here, this is false. And obviously, if this is false, it's going to be true, right? Now if I have 1, 1, and here I will have 1, 1, 1, I'm going to get false. However, if I put a 1, 1, 1 here, it's going to be true. So how do you think it works?
So it checks both the
Yes.
And then if they are the same rules like the other elements, and if one of the people doesn't have that element, it automatically says that the previous one is deleted.
Using or.
Louder.
Using or.
Or
The logic of or. Like if
A
or is
O
larger-
R, you mean?
OR.
Mm,
Because if it's the same, because there's a double n. So then it's if it's the same, then it's false, because it's not larger. But if one of the indexes in the list in the tuple is larger, then it's using the same logic of or, as if it's true or false, it's true.
right, but the order of the comparisons doesn't matter.
Well, going through each index, it's using the or logic.
Because or is commutative, right? To me, that's I don't understand how an operation that has, in which the ranks are ordered, would be modeled by something that where order doesn't matter. You see what I mean? So you look at every rank separately, right? So look at rank 0, the first element of both tuples. If the decision can be made from that alone, the decision is made from that alone. Otherwise, we move on to the next rank. That's essentially how it works. So in this case, 2 is smaller than 3. So that's enough. I'm done. 2 is smaller than 3, then 2 and anything is smaller than 3 and anything. Is it clear? Here, 2 is greater than 1. So 2 and anything is greater than 1 and anything. Okay? It doesn't matter what doesn't matter what I have here, doesn't matter what I have here. I compare 2 and 1, I already can say which one is. So it is very similar to the alphabetical ordering. Yeah? And then if one is shorter than the other, and by just going, I went through them and I went through the shorter one and compared all the ranks with the other one, and I couldn't decide, then the shorter is smaller than the longer. Okay? So it's exactly like these were letters, and letters are made into strings, and we are comparing alphabetically. It's exactly the same thing. For this reason, this is called lexicographic ordering. Right? It's a form of ordering. If I already have an order on the elements, then I can immediately infer an order on the sequences of those elements lexicographically. This also works if you combine types. So I can say 1 and A, right, is smaller than 3 and B, and this should be false. Sorry, true. Yeah, if I say greater, it's going to be false. Right, and again, it doesn't matter. It doesn't matter what the second one is. Right? If I say 1 here, then I say C or X, it's going to be true. It's important that rank by rank, elements are comparable, and elements are comparable only when they are of the same type. So if I'm going to go here and say 4, I'm going to get a type error. Why? Because 4 and B is not comparable, right? Even if this is 2, if this is 2, I don't get to the point of comparing 4 and B, right? And therefore, I don't get an error. But should I get to that point? So whenever you are assembling tuples or lists of elements, you should try to make them the same type for each rank. Cool. Okay? So what I wanted to point out is that let's make these into tuples. I'm just going to delete the 1. And we're going to notice now that our program works fine. Right? So I'll say that 2, 1 is this pair here is the smallest, right? Because 2 is the smallest of all. One thing that would have been interesting here would be to add another 2 and 10, for instance, and run it again, and see that 2, 1 gains or wins against 2 and 10. Is this clear? Yeah. Cool. Sorting. So def sort 1. We have a list of numbers, let's say. Okay? So let's remember a very important sequence function on sequences. And I'm going to say help of the empty list, because the empty list is a sequence. And did I say help or dir? Sorry, dir. And I want to remind you of this function called remove. All right, meaning that if I have a list L equals, let's say, 5, 3, 5, 2, 3, 4. Okay, let's repeat some of the elements because it's important here. And I want to remove one that is 3, for instance, that appears multiple times. So I can say L remove 3, and L now doesn't have the first 3. All right? So it only removes one occurrence if that occurrence exists, right? What if I try to do this again? It will remove the second one. What if I try to do this yet again? I'm going to get an error, right? So I have to remove only elements that I know to be contained for sure in my list. Okay, so what's a very simple idea? Let's start with the very basic thing. L is a list. Therefore, we have 2 cases. If always, right? You have to think of the fact that the list might be empty. So this is a simpler case. If the list is empty, what's the sorted list? Louder. Empty list, right? And I'm going to try to return L because I don't want to say the empty list. It's the empty of whatever type L is, right? I want to keep it polymorphic. Else. So if I have at least one element, what's going to be the first element of the result? What's going to be the first element of the result? So if my list is this, the minimum, very good. So let's compute the minimum with one of the minimum functions that we have already used. So my min, by the way, so this should be my sort. I want to make sure that it's well understood that we're playing here. We're just doing our own thing, because these already exist. So my min of L, right? And then what's going to be the result? Return, sorry. So the first element is M. I'm going to put M into a list and say plus, right? What's the rest? My sort. L. L what? Mm-mm. Why did I just show you this?
Oh.
Just because I wanted to make conversation, or okay? So I know for sure that M is in there, right? I wouldn't obtain this result if M wasn't in the list. So when I remove, I'm sure not to get an error. Okay? So this is one sorting method, which is actually called selection sort. Right? I go and select an element, which is the minimum, and remove it from the list, and then recursively sort the whole thing. Okay, so let's take a test list.
That's the my sort one.
Again, please.
After return, that's the my sort one.
My sort one, that's very good. Yes, absolutely correct. Let's make this one longer. All right. After sorting test list, we get my sort one. Object type none type has no len. How do I get there? So if I have a list of one element, I go get the list of one element, return M plus my sort of, and it's the empty list.
Maybe we can put elif like len is equal to 1.
No, but what would that solve?
Because like when there is one element, it removes the element, so that's why it becomes an empty list. And when it's an empty list, it returns an empty list, and that's why it cannot.
No, but you see, the only way I can get a none is from my min, right? This is the only thing that returns a none, right? Now, so it means that this M does it throw? It didn't throw, right? Trace back. Okay, let's do a print L here. It's okay, we need to learn how to debug as well. So I start with this, and immediately after that it's none. So I start with long list. L remove M becomes none. So if I have a list 1, 2, 3, so how do I get the none? So L is a long list. It's not equal to 0. I will do M equals my min. Let's do print M here. So I'll get 1, which is correct. Ah, okay, so I'm very biased by functional programming. Sorry about this. So what happens is that, let's say I have a list to explain the bug. 1, 2, 3, 4, right? So I'm very used with the setup where I perform an operation and I'm expecting that a new list is created, a new object is created, and the old one is left alone, right? What happens when I do this is, you see there's no result. Let me start again, and let me say x equals, and x now is none, right? What actually happens when I do this is that the list L that we originally used, right, has fewer elements. Because of that, and yeah, so that's the procedural way of programming. Let me just remove these. This actually doesn't have a value. So what I should do is put this here. Now list L is smaller, and I can do my sort 1 applied to L. Does it make sense? It's a very subtle difference. And one that can bite you in the behind very badly. So this will now work, right? So in spite of the fact that many elements are repeated, right, the problem nevertheless is that we have consumed the original list. So when we print here, this list is empty, unfortunately, right? So in order to avoid that, we can make a copy of the list. How do we make a copy of the list? Well, I'm going to say that I take the list from the beginning to the end. So when the beginning of the range is the beginning of the sequence, I don't have to write anything. When the end of the range is the end of the sequence, I don't have to write anything. So this will make a copy on the fly. And this is also nice, a nice thing about Python. And now we see that this is the original list, and this is the result. And probably would be nice to have them on separate lines so that it's a bit more legible. This is method 1. Let's find another method. Who can suggest another method? So let's do one that works only for lists, takes advantage of the fact that lists are mutable. And it's called bubble sort, and I'm just going to call it bubble sort. Okay? So I'm going to start with the assumption that the list is not sorted initially. And then, have we talked about while loops? If not, we introduce them now. So, new construct. While, we're going to repeat the following computation while some condition is true. So, while not is sorted, not sorted, and whatever comes below we're going to keep repeating, right? So I'm going to look at consecutive elements, and if they're not in the correct order, flip them, right? So for I in range, and I'm going to start from 0 and len of L minus 1, right? Because if I'm going to look at pairs of elements, there's L length minus 1, right, of those. And if Li is greater than Li plus 1, I should swap them, right? So how do we swap? Well, I need to use some auxiliary storage, and I'm going to put one element in this auxiliary storage. I'm going to save it so that it is not lost. Then this element that was saved can take the new value, right? Can be made to the contents of the temporary storage. So this AUX is temporary storage, right? So these three instructions swap two elements of the array, right? If they're in incorrect order, we swap them, right? Now, if we have performed at least one swap, we cannot be sure that the list is sorted. So I'm going to say that is sorted, right, equals false. Now, why do I do that? I do that because we're going to check for sorting based on the fact that this swapping never occurred. If this swapping never occurred, if this test was never true, then the sorting is in place, right? So I'm going to make the assumption here that the sorted is in place, right? Sorry, not here. Right? So I'm going to start with this hypothesis that it's true, and I'm going to invalidate it as soon as I found such a pair. As soon as I've done this once, I can no longer be sure that it's true. So I'm going to say it's false. Okay? And this is it, right? So initially, I'm going to make sure, I'm going to assume that it's false. Because of this, we're going to start executing the while loop. Inside the while loop, however, I'm going to do many passes. At the beginning of each pass, I'm going to say, oh, maybe it's actually true. Maybe sorting is true, right? And I'm going to go and check pairs of consecutive elements. Each time I have to do a swap. At that point, I can no longer be sure. So I flip the flag, right? If I have an entire pass, and during that pass, this was always false, and therefore I never swapped, at that point I can be sure that the sorting is in place, right? And how does that materialize? because this never gets executed, right? Whatever was set here will continue to hold, which is true, right? If it is true, this will be false, and therefore we're going to exit the loop. Okay? This sorts the list in place. It doesn't produce a new list, but rather sorts it in place. It doesn't use extra storage, right? Therefore, we're not returning anything. We're going to pass L into bubble sort, and at the end, we're going to inspect L and expect it to be sorted, right? So then we're going to have the same, we're going to need to have the same trick of copying the list. So here we're going to replace this with bubble sort, and then we can't do it this way, right? So I have to take this out, and I'm going to say test list. I'm going to say result list. We make a copy, right? And here we test result list. And we get result list here. Okay? So it works a bit differently. We make a copy on the prospective result list. We apply bubble sort to the result list. After finishing bubble sort, the result list has been changed to be sorted. Contains the same elements, but in sorted order. So this is what we can print now. And it works very, for some reason, sometimes it wants to compile, sometimes it doesn't want to compile. Sometimes it's very fast, sometimes very slow. So this time was very fast. And you see the after sorting. Let's make sure that this is after bubble sorting. Why do you think it's called bubble sort? Very quickly. Let me look for bubble. All right, so okay, so look at the animation, right? This is what happens. So you see, during the first round, the first element bubbles up to the end, like a bubble of air in the water. The largest element, after the second round, the second largest element bubbles up to its place. Right, so I'm gonna start again. Right, so look, 9 is the largest element, right? And as soon as it gets picked up, 9 keeps going, and 9 keeps going, and 9 keeps going, and 9 keeps going, right? So once during the scan we reach that place, 9 is picked up and then keeps going and going and going and bubbles up to the end, right? Then the second largest element in the second round, right? Once it gets picked up, it bubbles and bubbles and bubbles up to the end in the right position. Okay? So because of this, we can actually perform an optimization. This is why we call it bubble sort, right? So the largest element always bubbles. There's an optimization we can perform, right? At the end of the first round, right, the largest element has reached the end. Because it's the largest, that's never going to be moved, which means that in the second round, I don't need to go up to this point. I can go up to len L minus 2. Right? In the third round, I can go to up to len L minus 3, right? So we're going to start with a j equals 0, right? And if this range is shorter, this range gets shorter and shorter and shorter, I'm going to do fewer, I'm going to scan shorter distances, right? And here, j actually is going to be 1, and I'm going to do len L minus j, right? And at the end of every round, I'm going to say j minus equal 1, right? So this is a optimization. Yeah? Make sense?
Should we increase it by 1?
Yes, good point. Actually, we should increase it by 1. Yes. Very good. Means that you're following. I was testing you. All right, so if we go back, we're going to get the same result. Okay, and one thing that we can actually check is the number of comparisons that we're doing. So let's do it with the j and without the j, right? So I'm going to start with a count of 0 equals 0, right? And inside here, I can say I can increase the count, right? How many times we perform this comparison, right? And at the end, because so far we haven't been returning anything, I can actually return this count. Okay, so let's check how many comparisons we do. So here I am going to use another count equals bubble sort and print count of comparisons okay, and the previous version didn't have a j, so what I'm going to do is just comment out everything related to j. Here I can't comment out, I'm just going to delete this, -1. And let's comment this out, right? So let's see what the count is going to be this time. 238 comparisons, right? Let's go here and put it back. So j equals 1, len minus j, j plus equals 1, right? And let's see how many comparisons are we getting now. 147. Yeah, quite a few less comparisons. Cool. Questions? No? Thanks for coming. See you next time. Next time we're going to do